back. Today we're going to be talking about the real number system. This involves a lot of vocabulary, so let's get started by taking a look at a few definitions. So a few things that we need to understand before we begin is that real numbers are all the values on a number line. So if you can put the number on the number line, whether it's a decimal, fraction, whole number, negative number, all of those values can be placed somewhere on the number line, so all of those numbers are real. Real numbers can be classified using subsets, and a subset are groups of numbers with similar characteristics. Now let's take a look at the different subsets. So the different subsets that we'll be talking about of the real numbers are natural, whole, integer, rational, and then on the other side, irrational. Notice that natural, whole, integer, and rational are all related to one another, while irrational appears to be off on its own. And now let's talk about each individual subset so we can understand why that is. So here we're talking about both natural numbers and whole numbers. Natural numbers are also known as counting numbers. So when you start counting, 1, 2, 3, 4, etc. So some examples are 1, 5, 81, 990. All of these numbers are positive, they're not decimals, they're not fractions. Whole numbers include all of the natural numbers. So 1, 2, 3, 4, they're also whole numbers. So they could be natural and whole. They could be more than one thing at a time. The set of whole numbers, however, also includes the number 0. So when you're talking about whole numbers, it's 0, 1, 2, 3, 4. When you're talking about natural numbers, there's not the 0 included. Now let's take a look at the next two sets of numbers. Here we're talking about integers and rational numbers. Integers are whole numbers and their opposites, so 1, 2, and then -1, -2, because they're the opposites. Integers can be both positive or negative, and integers cannot have decimals or fractions. So an integer, -1, -2, +4, 790, -1002, all of those are integers because they are positive and negative, and they don't have decimals or fractions. Rational numbers can be written as fractions, terminating decimals, or repeating decimals. A terminating decimal is a decimal that ends, so 1.6 or 1.12. All of those numbers end. A repeating decimal is, for example, 1.3 repeating, so 0.3333 on until infinity. Rational numbers can be written as a fraction where a and b are both rational and b can't be 0 because you can't have a fraction with 0 in the denominator. So as long as you can write the number as a fraction, it's a rational number. So if you can write it as a ratio, it's a rational number. Now let's take a look at irrational numbers. Irrational numbers are numbers that never terminate or never repeat. So some examples that we have here are the square root of 45. Square root of 45 is not a perfect square. All non-perfect squares are irrational numbers because they're decimals that go on and on and on. They never end and they never repeat. Another very famous example of this is pi, because pi again is a number that goes on forever and ever and does not repeat. So you can see there my other example, 0.3456, and you can see the 3 dots, also known as an ellipse, letting you know that it's going on forever and ever. Now let's take a look at this in a few different examples. So here we've got an example of classifying numbers practice. So we're going to practice putting these numbers where they belong. The key is if we see a number that's not simplified, that we need to simplify it before we determine where it goes. So for example, the first one says 24 divided by 3. We can say, oh, it's a fraction, so it must be a rational number. However, 24 divided by 3 can be simplified to the number 8. And since the number 8 is a natural number, I need to put it in the natural number, but I want to make sure that I write it as the original number that I was given. So in this case, I was given 24 divided by 3, so I need to make sure that I have 24 divided by 3. The next number that I see there is 3 pi. Now, I don't need to know what 3 times pi is because as soon as I see pi, I know that that is going to be an irrational number. So anytime that I see pi is getting involved, I know that's going to be an irrational number. The next number we have is 0.6 repeating, and we know that repeating decimals are going to be rational. It can't be an integer, can't be a whole number because it is a decimal, but because it is a decimal that repeats and not a decimal that doesn't end and doesn't repeat, it is going to be a rational number. So 0.66 repeating is going to be a rational number. The next number that we have there is -6 divided by 2, but again, that can be simplified. 6 divided by 2 is going to be 3, with the negative sign is going to be -3. So our -3 doesn't have a fraction, doesn't have a decimal, but it's not a whole number because it is negative. So we need to put it in our integer spot, so -6/2, writing down our original number. And the last number that we have there is 0, and we know that 0 is the thing that makes the whole numbers different than the natural numbers, so 0 is going to be in our whole number. Now let's take a look at some more vocabulary. Based on the picture that we see here, we have a Venn diagram where whole numbers are completely inside the integers, as we know. Based on the picture, we see that all whole numbers are also integers, so they're two things at the same time. Just like you may be a student within your classroom, but that also means that you are a student within the entire school building. You can be both things. You're a student of the class that you're in, and you're a student of the entire school building. Some examples of whole numbers that are also integers are 0, 3, 57. Those are all whole numbers, and they are also integers. Some integers that are not whole numbers, though, are like -4, -6, -576, because those are negative. So whole numbers are also integers, but integers are not also whole numbers. Now let's take a look at this with a few more examples. So here in example A, it's asking us two questions. It's saying, what is the subsets that -6 belong to, and what are the subsets that the square root of 49 belongs to? So there's going to be more than one right answer unless they're only irrational numbers or only rational numbers. So taking a look at -6, we know that because it's a negative, it doesn't have a fraction, it doesn't have a decimal, so we know that we can place it in the integers box. So if we place -6 in the integers box and we need to include all of the subsets that it belongs to, then we know that -6 is an integer as well as a rational number. So it belongs to integers and rational numbers. For the subsets of the square root of 49, we first have to simplify the square root of 49. So the square root of 49 is 7, so that we know that's 7, and 7 is a positive number. It doesn't have any decimals, it doesn't have any fractions, it is a counting number. So we know the square root of 49 is a natural number. So to include all of the subsets to which this number belongs, we need to know that the square root of 49 is natural. It's also a whole number. It's also an integer, and it is also rational. So it is all of those things at the same time. Now let's take a look at example B. Here in example B, it's asking us to determine if these products and sums are rational or irrational. So we've got like a rational number times an irrational number, then we've got two rational numbers added together, and then we have an irrational and a rational number added together. So here is the key. We don't actually have to add these or put them in our calculator. We just need to know that any time that an irrational number gets involved, then the outcome, the sum or the product, or the quotient, for example, is going to have an irrational outcome. So the first one, we have a rational number times an irrational number. And it doesn't matter what that rational number is. We can see that one of the numbers is going to be irrational, so our outcome is going to be irrational. The next number we have there, next problem we have there, we have two rational numbers added together, so a rational and a rational. Since I don't see any irrational number getting involved, I know that my outcome is also going to be rational. And the last one that I have there, I have an irrational and a rational number, and I see that an irrational number is getting involved, so therefore my outcome is irrational. That brings us to the end of this slide. It also brings us to the end of this set of notes. So if you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.